In this video, we're talking about how to find the weight of an element inside of a molecule. And in this particular example, we've been asked to find the weight of just the oxygen in 36 grams of water. So what we're talking about here is water, and we know that water is H2O, which tells us that it's made up of 2 hydrogens and 1 oxygen. And we've been told, and these aren't correct because obviously molecules don't have a weight in grams, they have a very, very, very small weight. But we're just going to use a totally different weight to make this problem easier and give you the idea. So we're going to pretend that oxygen weighs 16 grams and hydrogen weighs 1 gram. That's 1 oxygen and 1 hydrogen. So what we want to do is figure out how much the oxygen would weigh if we have 3,600 grams of water. Well, what we need to realize is that we can set up a ratio for this problem to figure out how much the oxygen will weigh in 3,600 grams of water. So 3,600 grams is the total weight of the water, which means that we need to find the weight of 1 H2O molecule in order to get a ratio. So if there's 2 hydrogens and 1 oxygen in 1 water molecule, then in order to find the weight, all we have to do is take 2 times hydrogen. So we have hydrogen here at 1 gram. So we'll take 2 times hydrogen of 1, and then add to that the weight of 1 oxygen molecule. So plus 1 oxygen is going to be plus 16. And when we do that, we're going to get 2 plus 16 and a total of 18. So the weight of 1 water molecule is going to be 18 grams. So when we set up our fraction, we want to say the total weight is 18, and the total weight I'm looking for is 3,600. So this is the weight of 1 molecule, this is the weight that I'm looking for. So remember, I want to find just the oxygen in this 3,600 grams. So what I'm going to do is set this ratio equal to another ratio. I'm looking for the total weight of the oxygen in 3,600. So again, I have 1 molecule and the total. Over here on the right, I need to have 1 molecule in the numerator, total in the denominator, so that it matches this form here. Well, what I'm looking for is the amount of oxygen in this total 3,600 here. That I don't know yet, so I'm going to put X in its place there. What I do know is the oxygen in 1 molecule. Remember, there's 1 oxygen in an H2O molecule here, and I know that 1 oxygen weighs 16, so I'm going to put 16 here. In other words, you could say it this way. If oxygen is 16 grams of the total 18 grams in 1 molecule, so if in 1 molecule it's 16 out of every 18, how many is it in 3,600? So that's how we set up our ratios, and when we have 2 fractions set equal like this, we can solve for x. The way that we're going to do it is to multiply both sides by x. So when we multiply both sides by x like this, we're going to get x and x to cancel on the right hand side. We're going to distribute this x across both fractions. So x times 18 over 3,600 is going to give me 18x over 3,600. And then on the right, I'll get x in the numerator to cancel with x in the denominator, and I'll just be left with 16. Now my next step would be to multiply both sides by 3,600. But before I do that, I need to notice that I can actually reduce this fraction on the left. I have 18 over 3,600, and I can divide 18 into both of those. 18 divided by 18 just leaves me with 1, so I'll just be left with x in the numerator. 3,600 divided by 18 is 200, so I'm going to have x over 200 is equal to 16. Now instead of having to multiply by 3,600, I only have to multiply by 200 because we were able to reduce that fraction. So I'm going to multiply both sides by 200. That'll get my 200 over here in the denominator to cancel with this 200 in the numerator. So that's just going to leave me with x on the left-hand side. On the right-hand side, 16 times 200 is going to give me 3,200. And since we've been working in grams, I can call that 3,200 grams. So what this tells me is that if in a single molecule of water, the oxygen makes up 16 of 18 total grams, then I know that if I have 3,600 grams of water, the oxygen is going to make up 3,200 grams of that 3,600 grams.